Good morning. Well, maybe it's not the morning for you. Maybe it's not the morning for me. I guess you'll never know. So today we're going to continue on simplifying products and quotients of radicals. Let's get to it. So first we need to know the properties of exponents, because remember, now we understand that all radicals can be written as an exponent. And so those properties of exponents are still going to hold true whether that is an integer or rational exponent. Doesn't matter. So we have our product of powers. If we multiply the bases, we add the exponents. If I have a power raised to a power, then I multiply the exponents. If I have two bases multiplied raised to a power, then this is the time I can actually distribute the exponent. We have seen if I have a base raised to a negative exponent, I can write that as a positive exponent by putting the whole thing in the denominator. Anything raised to the zero power is 1. If I have a division of bases, I can subtract the exponents. And then this is very similar to the power of a product, where if I have a quotient or division inside of a quantity raised to an exponent, and as long as I don't have addition or subtraction, then I can distribute this to each term in the numerator and denominator. Here are some examples. Let's do some practice. If I went too quickly there, you can always go back, pause the video, and write down what you need. Those are properties, most of which you have seen before, all of which you need to know. So we'll do a couple together, and then I'll have you do the rest. All right, let me get my pen. All right, so let's look at the first one here. So I have 5 to the 2/3 times 5 to the 4/3. So if I go back here, that is the product of powers. So I know I'm going to add the exponents. So this becomes 5 to the 2/3 plus 4/3. Remember, when we add when we add fractions, we need a common denominator. Conveniently, this already has a common denominator, so once we get the common denominator, then we just add the numerators. So this becomes 5 to the 2 plus 4 is 6, so it would be 6/3, but what's 6/3? That is 2, so this becomes 5 squared. In terms of understanding our properties, we want to make sure we know that, but we know 5 squared is 25. So 25 is our answer. Questions? Okay, let's jump to one of the division ones. So this is going to be our quotient of powers. So if I have division, I subtract the exponents. So I'll write this as 8 to the 5 over 2 minus 1 over 2. Similar to addition of fractions, I need a common denominator. Coincidentally, again, I have a common denominator. This is great. So this becomes 8 to the 5 minus 1 is 4. So 4 over 2. 4 over 2 is 2. And 8 squared then is 64. Boom. Not bad. Okay. I want you to try to do B, C, D, and F. Pause the video, unpause when you are ready to discuss those. Okay, so for B, I did 3 to the 1/5 plus 4/5. Again, the denominator is already common, so that's nice. 1 plus 4 is 5, so 3 to the 5/5 is the same as 3 to the first. Anything to the first power is just itself, so that is 3. Here, we hadn't done one of these examples together, so this goes back to our power of a power. So we're going to multiply the exponents here. So 4 to the 2/3 to the 3rd. So 2/3 times 3. Remember, if I have just an integer, that's the same as 3 over 1. And remember, when we multiply fractions, you multiply the numerators and you multiply the denominators. So 2 times 3 is 6. 3 times 1 is 3. So I end up with 4 to the 6/3. 6/3 is actually 2. So 4 squared is 16. Similar for D, same thing. I have a power raised to a power, so I'm going to multiply those. Here I kind of jumped already to the second part. 1/2 times 4 is 4 halves. 4 over 2, or 4 halves, is actually just 2. 10 squared is 100. And then F. So F, we have to do subtraction again. 2/3 minus 5/3 is negative 3/3. Negative 3/3 is actually just negative 1. If I have 7 to the negative first power, I can write that as 1 over 7 to the positive first power. I don't need to write the positive 1, though, because of the negative exponent. Any questions? questions? All right, nice work. Oh, and one more thing, in the directions, I didn't really talk about this, but you could use your calculator to check any of these. So if you type 5 to the 2/3 times 5 to the 4/3 into your calculator, you should get 25. If I type 10 to the 1/2, close the parentheses, and then raise that to the 4th, I should get 100, and so on. So that's how we can definitely use our calculator to check these. All right, so next thing we're going to talk about are properties of radicals. So for radicals, we have the product property and the quotient property that we're going to talk about today. So the product property tells us that if I have a radical of any index and I have a product or multiplication inside of that radical, then I can split that radical up into two separate terms that are multiplied with the same index. This works in both directions. And so that's what we see in our example here. So for the example, we actually start with this side of the equation. We use that to combine the radicals. So 4 times 2 is 8. So I have the cube root of 8, and then that simplified to 2. Similar sort of thing with division. So if I have, this is called our quotient property because it's division. If I have a radical over a fraction, then I can separate that fraction so that the radical is over the numerator and denominator separately. Or, again, I can go from, in this case, the right-hand side of the equation to the left-hand side. If I have if I have a numerator and denominator of a fraction with the same index of a radical over each, I can combine that into a single fraction. And that's what we see here, or I'm sorry, into a single radical. And that's what we see here. So I have the 4th root of 162 over the 4th root of 2. I can combine this into the 4th root of 162 over 2. 162 over 2 is 81, and the 4th root of 81 is conveniently 3. Okay, let's do some examples. So we'll do a couple together again. Here I'm just going to jump right into, let's do C together. So the 4th root of 27 times the 4th root of 3, I know I can combine these, and here I'm showing you more work than what you actually need to show. So the 4th root of 27 times 3, which is 81. So this becomes the 4th root of 81. And we just saw from the example here that the 4th root of 81 is 3. If I didn't know that, I could try and type that into my calculator or break down that 4th root. So this becomes 3. Let's look at a division problem. So let's go ahead and jump to E. All right, so for E, I can rewrite this as the 4th root of 4 over 1024. Now I could type that into my calculator and use my calculator to help me simplify that fraction. And this is going to become the 4th root of 1 over 256. And now I'm actually going to separate this again, and I'm going to do the 4th root of 1 over the 4th root of 256. I can use my calculator for the denominator if I don't know it, but the numerator, the 4th root of 1 is 1, and the 4th root of 256 is going to be 4. And again, I got that from my calculator. We have seen how to type that in. So I end up with 1/4. All right, so I want you to try to do A, B, D, and F. Pause the video, do those, and pause when you're ready to discuss. All right, so again, I'm going to be showing you more work than what you actually need. You could have gone right from the initial part here to showing the square root of 36, and I know the square root of 36 is 6, but how I'm getting that is I'm combining this with the multiplication, so 3 times 12 is 36. Root 36 is 6. So here I have the cube root of 5 times 25. 5 times 25 is 125. The cube root of 125 is 5. We already did C. So D, the square root of 98 over the square root of 2 is the square root of 98 over 2. 98 over 2 is 49. The square root of 49 is 7. We already did E. F, the cube root of 625 over the cube root of 5 is the cube root of 625 over 5. 625 over 5 is 125, and the cube root of 125 is 5. And again, I can use my calculator to help me with that. That is one of them that I did talk about earlier. I would recommend knowing, the cube root of 1, or 1 cube, 2 cube, 3 cube, 4 cube, and 5 cube. Those come up quite a bit. If you know more, that's good. But if you don't, you can always use your calculator to help. Okay, so one of the big things is understanding that our properties of exponents hold true even if the exponent is not an integer. We saw that earlier on with that table of all the properties of exponents. And then also making sure we know our properties of radicals. So the product property and the quotient property of radicals is going to be very important for us in this unit.